So we have finished creating relationships between tables. Now we can move to database performance optimization. Let's start from indexes. Let's open up let's start from sales data table, because the largest table is this, and the most important data is here, and we are going to use this table for our day-to-day queries. So let's start from indexes. Transaction ID is a primary key in this table, and if we didn't mention any column to be clustered index, on primary key column by default is created a clustered index. In this case also on this column is created a clustered index. Let me show this. We go to indexes and we see that on this column we have a clustered index. We can create another types of indexes also. We can create a non-clustered index. Creating a non-clustered index on particular column makes sense if we use the column frequently. For example, on date column makes sense to have a non-clustered index, and makes sense also on amount column. So we can create non-clustered indexes on these two columns, but it's not a good habit always to have non-clustered indexes on the all columns, because it takes space, it takes memory. So when we create a non-clustered index, there is created another table which has two columns. Let's say if we create a non-clustered index on transaction date column, that new table contains two columns. In first column are placed all dates, and next to it in the other column references to the rows. So when we do a query, let's say right select everything from sales data where date is equal to, let's say, this day, it goes and checks all the references. In the second column, which I mentioned, are kept all the references. Let's say if we do by this date, in the column are row numbers where we have these dates. So that's why it takes space, and it's not a good habit to have non-clustered indexes on the all columns. Now let's create a non-clustered index on this column, but let me show, let me open up new tab. Let me show the benefit of creating non-clustered index. Let me query something. Select everything from sales data where transaction date is equal to, let's take this let's say day, and let me include actual execution plan and see how much resources it takes. We see that it takes estimated sub-tree cost is 10.61. okay, and here we see that actual number of rows read is more than 1 million. So overall it took 0.1 15 seconds here and 0.26 seconds here. So overall it took 0.41 seconds. So now let's create a non-clustered index on that column and check again how much resources that will take. Let's do create index sales data, transaction date, sales date on sales data, transaction date. Let me run this. We have created an index. Let me refresh this tab and show the index. So this one is the index which we created. Now let's run this command again, and we see that this execution plan should be read from left to right and from top to bottom. So you see that here, if we look, we see that actual number of rows are 430 only, and there without index there was more than 1 million. And of course time also execution time also is reduced. So we see that all these numbers 0.011, 0.005, all these times are less than 0.1 seconds, but without indexes we got 0.41 seconds. So we see that creating an index helped us to improve the performance. So let's now go ahead and create another index on amount. We can copy this and paste here and write sales amount, and we need to change here the column and write amount. Oh, sorry. So we see that we have created another index. Let me refresh this again, and we have another index. Let me go ahead and create some restrictions. In this table, quantity is important because if we don't mention employee ID or the value for customer ID, that's bad, of course, but if we miss quantity, in that case we will have some misstatements in our financial statements. That's why let's because amount depends on quantity. So if quantity is not mentioned, that means that we cannot know how much was transaction amount. For that reason, let's set quantity as not null. Let's create a restriction. Upper column quantity integer not null. Now we have a restriction, and we can be sure that we will not miss this column value. Then we can go ahead and create. Also, we can go ahead and create a trigger on this amount column. Now we need to write amount manually, but when we create a trigger, it will automatically populate the correct amount. It will take product ID price, the price from this product ID, and will take the quantity as well, and will multiply the price by quantity. So let's go ahead and create a trigger on this column. Let's write create trigger sales auto sum, or sales maybe amount, on sales data table after insert as begin. Now we're going to update the table, update sales data, set sales data dot amount okay, is equal to let me now write here is equal to, I want to join two tables. Let me write from sales data, then inner join. Now I'm going to join in SQL, in Microsoft SQL Server. There are two auto-generated tables. Tables are called inserted and deleted. When we do insert or delete, there are auto-generated tables which are containing the data which is inserted or deleted, and there is not an updated table, but when we update something, that record is appeared in inserted and in deleted table as well. So I'm going to join that auto-generated table, which is which we call inserted, as, let me write this, I on sales data dot, we are going to join by primary key. Here we are going to write I dot. Look, when I do I dot, there are all the columns which we have in our main table. So I'm going to join these two tables, and the reason why I am joining these two tables is that if I don't join, if I don't ever include this inserted table, all the data will be updated. So when I insert new row, the entire table will be updated, but I want this to be applied only for new entries. That's why I'm joining this inserted table. Then I need to join also products table, because our price is in products table on p dot product ID is equal to sales data dot product ID, and now we need to write here set sales data dot amount is equal to p dot amount, actually selling price, and here we can write I dot quantity. Okay, so this is our trigger. Let me run this. Okay, we see that our trigger is created. Now let's test this. Let's see how that works. Let me write select everything from sales data. Then let me write order by transaction ID descending. I want to see, oh sorry, top one. I want to see the last record. So our last record in this table is this one. So let me insert one more row into sales data. Let me write here month year key. Then let me write product ID. Let me write quantity. Values. Let me copy all these values from this row, product ID, and if I copy all these rows, we should see the same amount. Okay, let me run this. We see that it worked. Now let me run again top, but this time 2 rows, and we see that this one is what I inserted just now, and the amount is the same. The amount is the same, and we see that it works correct. Now let me delete that inserted row, delete from sales data where transaction ID is equal to, this is auto generated, we put identity on this column. Okay, that's fine. Now we can go ahead and check what we have else. Here we can create a constraint on fraud column, and we can set that by default to be no, and if something happens and the transaction is considered as fraud, we can manually put here as yes. Let me create alter table sales data, add constraint fraud default, like this. Default no for fraud. Let me run this command. So we have set a new constraint on fraud column. Let me check what we can do else. I think we are good to go here. We can now move to other tables. Let me quickly open up all the columns and see what we can do here. Category ID, category name, status. Okay. Those are small tables, and I don't want to create non-clustered index here on those. Country, industry, or some constraints. Employees, name, last name. address line, city, country, years in company. Okay, marketing expenses, year, month, year, key. Okay, notice period. Okay, products. I think we can create a trigger on this products table. That would be good if we had an opportunity to keep track on new added or deleted products, because if we have a new product and we want to analyze the results, the selling results, we need to know that how much time we already are selling our product, or let's say we deleted a particular product. We want to know how much time has passed since we stopped selling that product. So let's create another trigger on products table. So for that we can create another table, one more table. We can write this, name this as product history, and in this table we can have date. Let me write date. This date is the date when we started selling that product. This will be date time. Okay, and we can write for this date time, we can set default get date, get problem date. Okay, and it will automatically populate the date for us when we first time inserted this product into table. Then we can have product ID. Okay, this is going to be integer. Then we can have action. This will contain whether information whether the product is created or deleted. Okay, because we can also delete and stop selling some products. Let me create this table, product history, create report. Oh, sorry, I forgot. Right table, create table, product history. Okay, we have this table. Now in this, let me show this table. In this table we can keep information about new added or deleted products. So let's go ahead and create a trigger. Create trigger. We can name this as product add delete. This trigger is going to be on products table, and after insert and delete. Okay, as begin. Now we need to write a condition, because we here have an action column also. In this column we should mention whether a new product is added or deleted, so we need to have here condition. For this condition, write action as deleted, and for other condition, write action as inserted. So we need to distinguish two actions, insert and delete actions. So let's write if select everything from, actually no, select count from inserted table. This is the same auto-generated inserted table about which I was talking, is greater than 0. This means that I want to say that if this inserted table is not empty, meaning that if inserted table is not empty, that means that we have inserted something. Okay, and if this table is empty and deleted table is not empty, that means that we deleted something. But here we have a case when I was talking about inserted and deleted tables, I mentioned that there is no table updated, and when we do an update, in that case the particular record will be shown in both inserted and deleted tables. In inserted table will be shown the new value, and in deleted table will be shown the old value which we already replaced doing an update. Because of that, let's write another condition. Let's write select count from deleted table is equal to 0. That this means that we want to make sure that the operation was not an update, but it was insert. Let's write begin, then insert into product. Here we don't need to write the date column because it is set by default and will be auto-generated, so we missed that. Let's write action, and as values we need to write select product ID from inserted, and for the second value here we can write, let's say, added. And then for the next part of this trigger we write if, then copy this, paste it here. Here we need to write deleted, here we need to write inserted to 0. In that case we want to insert into, let me copy this again, select product ID from deleted, and we can write here deleted. Okay, and we write again and. Let me run this command. Oh, what's the problem? Oh, sorry, the problem is here. Let me run again. Okay, we see that now we have a new trigger. Now let's check how that works. Let me select everything from products. Let me run this. This is the products table. Now we can go ahead and insert something into this table. Let me write insert into products, product ID, values. We can write 56. Let me run this. Okay, let me run this command again. Now you see we have a new row here, which is information about insertion. Let me write update query also. Select ID. Let me run this. Let me run again this command. That's fine. It is not here. Let me delete this particular record. Okay, now let's see what we have. Looks good. We have information about inserted and deleted items, and this is exactly what we wanted to get. Actually, this action gave me an idea. We can add also information about updates, because here is not clear. Let's say if we didn't have product ID number 57, how it is deleted, or where is now product ID 56 if it was not deleted, but why it doesn't exist now in our product history table. So we can add information about updates also. Let's go ahead and add other columns, 2 columns to this product history table. One will be old product ID, and the second one will be new product ID. Let me do alter table product history, add old product ID integer, new product ID integer, and in these 2 columns we will keep information about updated products, and we will not have any more. Let me write, actually let me here write update. Okay, then we need to add one more condition. If, let me copy this, is equal to 0, is equal greater. By the way, we can write this command in other way. We can write exists select everything from deleted and exists select everything from inserted. We can write here begin insert into product history, and now we instead of product ID we are going to place two more columns, new product ID and old product ID. Let me actually copy this, paste it here, and this is going to be changed. This is going to be old product ID. Here we need to write new product ID, and for values, so this condition, this value is for old product ID. Let me copy this, paste it here, and right from insert it, this is new product ID, and action should be updated. Okay, let me now delete this trigger, drop trigger. Yes, by the way, we need to rename trigger. Can write update here, or update. Let me run this again. What's the problem? Oh, we forgot here, right? And okay, let me copy this and paste it here. Then we can truncate product history table. Let me write truncate table product history. Let me run the command. Okay, now we need to repeat these steps again. Let me run again. Okay, we see new added product. Let me update this. Okay, now you see dates are placed here, action is update, old values are shown here, and new values are shown here. Let me test delete command also. Let me run the command. That's fine. I think this way is better than it was without update action. Now let's go ahead and see what other performance improvements we can do. Let me close this tab. Okay, so okay, then we have sales data, supplier. Let me open this table, supplier table. Okay, supplier salesperson table. Okay, and we have tax information table. Okay, we can go ahead and create a view. Let me create view. In this view, I think we can show sales of the current day. So we can current day sales as, So we can select, let me open up sales data again. Sales data, this is sales data. We can right select everything from sales data. Oh, sorry, sales data, where transaction date is equal to get date. We can do cost date as date. Okay, let me run this view. Now we have a view and can safely share this with other employees without fear that they will change something in the original database. So we did performance optimization. I think we are good to go. So all tables are normalized and all connections are established between tables. We can go ahead and do backup of this database. We can write here my shop OLTP full. So we have a backup of this database now.